holiday season, so I spent some quality time with my computer and did some hacking. This is a demo of something I'm calling Pail. It's a key value store. It's a bucket for DAGs. It optimizes reads by reducing DAG link traversals when it's retrieving a value for a key. And it's also pretty good for writes because it only shards when it really, really needs to. Pail is a library, but I also wrote this little CLI tool. And so the main command is called put, and you can put a key, like any string, and a value, which is always a CID. Pail doesn't deal with data, it just deals with IPLD links. So your values are always CIDs to some value. Anyway, so that's how it works. So let's see it in action. So what I can do is I can call Pail put with a key called ABCDEFG, and then some sort of, I don't know, this might actually correspond to some data, but I think it's just a random CID that I picked, and then that should, well, it adds that key to the bucket with that particular value, and what you get back is a diff. The output here is just kind of diff-like. So the first change up here is like, this is the root CID of the whole DAG, and this is the root CID of an empty shard in the DAG, and it's being replaced with this this root CID, and then below here is like the individual blocks that were removed and added to the DAG. So we removed obviously the root one, the old empty shard, and we added this new root. So we're just, we're one shard DAG at the moment, and that's what we have. And so we can put some more keys. So what I did was I made it, because for the example, for the demo, there's no like the actual data CIDs don't matter. I made this script to generate just like a CID of a random of some random data. So we can put some values using this script. Just generates me a random CID. So Pail put, I'm going to put something else key, get another diff out. I've got one called foobar baz. I've got one called food, and another one called foobar was. Okay, so we get a diff every time, but you can see each time we do a put, we basically if this is the new root CID, we remove it in the next call and add it, and we get a new one. And so this is the new one, got removed, got a new one. So there you are. And what you can do with this command line tool is you can do like a Pail ls to list out the things in the bucket. So these are our keys that we put in. We put A, B, C, D, E, F, G. We got foobar vaz, foobar woos, food, and something else. So you'll notice that these are all lexicographically ordered. So that means that anyone who's using this library can sort of define the sort order. And we can do awesome things like prefix matching. So I could do a Pail ls-p, that's for, so the longhand is prefix. Prefix. That'll get me everything that begins with foo, of which there are 3 items, and then I can do like foob to just get the things that begin with foob. So that's pretty cool. Anyway, so this is all basic stuff. Let's take a look under the hood, and for that we will use a command called Pail tree, which actually lists, it's kind of tree output of the DAG structure that is that makes up the Pail bucket. Don't want to say it. I really want to say bucket, but yeah, Pail, the Pail that we're currently working with. Cool. So this is what it looks like. Our root is a shard, and it's pretty boring at the moment. All of our keys are in the root shard, and it's boring because Pail will only shard, start doing shard when its root, when a given shard, a block, exceeds 512 kilobytes. That that's a almost random number, so that could be might change in the future. But the idea is that I want to be able to be able to fit all of the data for a single letter key for all kind of single characters or ASCII characters at least in a single shard. Anyway, that's it's boring. Let's not talk about that. So that's Pail tree. Cool. And anyway, so the reason that we only shard at 512k is to kind of avoid these like unnecessary traversals. Every time we kind of traverse from one link to another link, we have to go and get a block from the block store or wherever it's coming from, and then read it and decode it and etc. So ideally, we don't want to do any sharding or traversals until we really, really have to, and that is at when the block exceeds 512 kilobytes. It also will shard if you give it a key that's like more than 64 characters long, so you can force a shard that way. Yeah, that's also a random number, but yeah. That's that. So what we can do is we can make it exciting by adding a key and forcing a shard by setting the max shard size. So what we can do is we can add. So here what we're going to do is we're going to add a new key called foobar BOZ with a random CID, but we're going to set the maximum shard size to 259 bytes, which is the current size of the root shard. So what that means is that when we try and add this key, it will exceed the max shard size and it will do some sharding. So let's have a look at that. So that goes in, and then we can do, so let's just Pail ls, let's have a look, check that went in. So that was foobar BOZ, which is now here in order, and then we can Pail tree. Ooh, check this out. So when the shard size is exceeded, a new shard is created. So this is a new block. So this key now links to this block, and this key is foobarb now. And so what happens is when you insert a new key and we need to shard, what we do is we find what I'm calling the LCP, the longest common prefix, and it has to. We use the insert key as a base. So in this case, we're using foobar BOZ as the base, and the longest common prefix with these other keys in here is foobarb. Because we took this as a base and we worked backwards through the string, and then we found that the longest common prefix with at least one other key, I should say, is foobarb. So then we matched with this one, and so that became a shard. So now we've got foobarb with as, which is foobarb baz, which is the key we just BOZ was the key we just put in, but baz was already there. So we end up with a kind of Pail that looks like this with this shard and two extra keys in here, but it now is less than the max shard size because we've removed a key and put it in another shard. That's kind of cool. What else can we do? We can obviously get stuff out of it, so we can get our food. Here it is. And we can do stuff like we can delete food. So let's just remove food. Obviously we get a diff from this. We just add a new. We removed the root block, but we've removed an item from the root block, and we create a new one. So that's the diff here. And then so Pail tree now looks like this. We don't have food in here anymore. That's cool. So yeah, let's add more stuff to this. So if I put, so to kind of continue the the sharding example here, if I put something called foopy with a max shard size of this is now 211. Let's have a look what happens there. So look, so in this case, our diff is more interesting because we've actually now removing just the root block, and we're doing some additions. There's more here because we're changing an existing shard, and adding. You'll see in a sec, adding a new one. So let's just check that. So Pail tree. Cool. So we've actually got a new shard. Here we go. Yeah. Okay. So so we put foopy, and because we take foopy as the base, the longest common prefix, working backwards through foopy, was actually ended up being foo, because these two matched. So we've got foobar was, and we're adding foopy, and the longest common prefix was foo. So we ended up with a new shard. We've got so this shard has the barb. So this is foobarb, essentially the foobarb shard that we had previously, which is I guess this is the same CID as before for foobarb, because actually the content of this block hasn't changed at all, but it is in a new shard which we added here. So this is why we only got two. Okay, so I'm figuring out exactly why I was confused just now. So we get two additions here because we've got a new block here, a new root. This one stayed the same, but we did remove the old foobarb. What do we remove? Remove the old root essentially. So that's the old root, which was old C. Cool. Anyway, okay, this is going not great, but do you understand? I hope. So we've got foobarb, which is the existing one. We've got foobar woos, and we've got foopy in there as well. We can do Pail get foopy as we did before, and we get foopy, that one, the value back. Lovely job. There we go. Cool. So, all right. So let's look at something a bit more interesting. Check this out. On your computer, there is this directory. Likely, if you're using like a Mac OS or Linux or something, and there's this file called words in it. There are lots of words, 235,000-ish. Words here, and this is the words that are in a dictionary written in the 19th century. This was last updated in 1993, so this is old. So this is like a English dictionary. Lots of words. So what I did was I took those words and I added them to a Pail. So if I head over to that Pail. Scripts, words, there we go. I can just like list them out, and there's a lot, but it's just what it's doing here is it's just reading that DAG and traversing it and spitting out the values to the screen, as you saw in previous calls to Pail ls. So anyway, that's all of those, 235,000 of them, pretty cool. And then obviously the prefix stuff works, so I can find the 179 words that begin with bat, starting with bat. And interestingly, batty phone is, I thought that was like a bat phone, like a Batman bat phone, but batty phone, anyway. It's like a clarinet. Anyway, so yeah, so we can do obviously with this Pail you can just like get words out and get the values, and again just to explain again the values that I've put in here are just random CIDs, but it's the keys that are the interesting bit. But anyway, so big Pail, lots of words, pretty fast at retrieving stuff and listing it out, so that's good. There's also this proper names file, which has like names of people in it. There's like there's not loads, but if I just Pail ls those, there's like 1,408. Lots of names of people. I put this in a Pail too, and so there's a lot less of these. So we can actually look at the tree for this, and this is just to give you a kind of, I guess, idea of what a Pail bucket looks like when it's got a bit more data in it. Excuse me. So look at all these. This is fun. So I went up to here before. So this is cool. Pablo, Paige, Pam, Pamela. So this is cool. This is kind of what it looks like. So we can do. Where we get Pam. Boom. Cool. And that's basically it. But it just shows you, you can put data in, put lots of data in. It does sharding, does prefix matching, listing, all of that good stuff. This is Pail, DAG-based key value store.